So good morning. Welcome back to another session of image processing. Myself, Dr. R. Sudhir Babu, Associate Professor, the Department of Electronics and Communication Engineering, G. Pullareddy Engineering College, Autonomous, Kurnool. So the last class we had discussed about the fundamental steps in image processing. So let me summarize what are the things that we had discussed in the last class. So the fundamental steps are image acquisition, that is nothing but acquiring image. Next, image enhancement is to improve the appearance of the image. Image restoration is also improving the appearance of the image, but there is a fundamental difference between image enhancement and image restoration. Image enhancement is an subjective process, whereas image restoration is an objective process. And the next step in the image enhancement will be color image processing. Next, wavelets and multi-resolution analysis. Next, image compression and the morphological image processing. Next, image segmentation, representation, and description. Finally, object recognition. And all these steps will be interconnected to knowledge base or database. So these are the things that we have discussed in the last class. Now let us continue with another topic. So the fundamental or the basic hardware requirements. Fundamental components of image processing system. So if you want to design and deploy an image processing system, so we need to have some 10 hardware elements, right? So we know, so in order to design any application, the things that we need to have is images. So the fundamental hardware requirement is imaging sensors, So this is a basic hardware requirement. So imaging sensor is nothing but it is basically a device that acquires the images. A device that acquires the image, right? So with respect to imaging sensor, the two elements are very, very crucial. The first element is a sensor, so which is reactive to the light that is radiated by the object from the scene. So the sensor has to translate the light that is emitted by the object in the scene into an electrical signal. And then, so in order to get a digital version of the image, so we need to have a digitizer, which will translate the output of the sensor, which is electrical output, analog electrical output, into a digital signal, so that finally we will be getting a digital image. With respect to imaging sensor, the two important elements are a sensor which is reactive to the light radiated by the object from the scene, and a digitizer which will convert the electrical output of a sensor into a digital signal, so that finally we will be getting a digital image which can be stored and processed through a digital computer. And along with the imaging sensor, this image acquisition design comes with a specialized image processing hardware. So this specialized image processing hardware helps to create a better version of the images. See, so during the image sensing, the image sensors may pick up noise along with the actual light. The imaging sensors pick up some kind of noise during image acquisition, so this noise has to be reduced. So for this purpose, image sensing devices or image capturing devices uses specialized image processing hardware, which will perform some primitive operations like image averaging, so which will helpful to reduce noise, so that the output of the basic image acquisition device is a clean image. Right. So with respect to image acquisition device, the two elements which are of importance are a sensor which is reactive to the light radiated by the object in the scenes, and a digitizer which will convert electrical output from the sensor into a digital signal. And finally, we'll be using a specialized image processing hardware which will perform some primitive operations on the image acquired, so that so the output of the sensor is a noise-free and better clarity image. And then, so all these things has to be processed by using a computer. Images has to be processed by using a computer. The next requirement in designing any image processing application is a computer. Yeah. So depending on the application at hand, the computer may be a simple PC to a supercomputer. So if you are designing a simple the face detection systems or iris recognition systems, or simple the fruits gradings machines and so on. So a simple PC with the standard requirements like a good RAM and a fair amount of hard disk and a fair processor is sufficient to design and deploy this entire system. But if application demands to process huge volumes of data and requires huge storage, then the people will go for supercomputers. For example, if the application is a weather forecasting system, weather forecasting or astronomical observations, weather forecasting or astronomical observation. So in this case, so one may need to use the supercomputers, so which will process the data at very high rates, or which will process the data in real time, so that we'll be getting the better predictions in the context of the forecasting, weather forecasting, and so we'll get to know so what is happening in the outer atmosphere, so during astronomical observations. So depending on the application hand, the computer can be a simple PC to a supercomputer. And so if you're using a computer, then the computer is associated with some hardware like mass storage. So in order to design image processing applications, we should have the huge volumes of the memory, right? So there will be a data connection between the storage and computer, and you may be knowing that the computer memory takes different forms like RAM, read-only memory, and hard disk, and even the flash memory and cache memory, etc. Right? Okay. And along with the storage, so we should have the image processing or specialized image processing softwares. Yeah. So we cannot use the regular software in order to process the data, the image data, because it may take some additional times to read the data and display the data. So we need to have a specialized image processing softwares like Python or MATLAB. Yeah, so your computer should be installed with softwares like Python and MATLAB in order to design the image processing application, so that data reading and writing, that means the data retrieval and the storage and the processing will happen at a quicker rates. Right. So once the data is processed, that must be displayed somewhere. So we need to see the outputs. So in order to see the outputs, the computer is associated with image displays. Yeah, so image displays may range from CRT display or LCD display or LED display. Yes, there are multiple technologies of displays available, and depending on application of interest, we will be using the different varieties of displays. And so if you want to take hard copy of anything, process data, so we need to have hard copier. So which is basically a printer. Yeah, so this is the standard hardware requirement to design any image processing application, right? So we need to have the image acquisition system. So with the sensor and ATD converter and a specialized image processing hardware. So the problem domain, the sensors, the acquisition device will capture the images of problem domain. So I said we already discussed what you mean by problem domain in the last session. So depending on the application at hand, we call the application as a problem. So it will be the capturing image from that domain. Example, face detection. So only face of the persons, iris recognition, the iris of the image, etc. So that is what is called problem domain. So the depending on application. So this is the basic hardware requirement in order to build a image processing system. Right? If application demands the data to be transmitted from one place to another place, the NUT system must be connected to a network. A system must be connected to a network so that the data can be transmitted from one computer to another computer or one place to another place, etc. Right. So this is the basic hardware requirement or the fundamental components required for building a image processing system. So we'll stop the discussion here, and so we'll resume our discussion with a new topic in the new session. Thank you.